Hi everyone, so today let's solve a Leetcode question called case most element in binary search tree. So what is binary search tree? Well, binary search tree is a special type of binary tree where the left child has smaller values and right child has greater values. So let me look at the example here. In this example, we have 3 as the root node, and we found, okay, the left child is 3 is this 1, so this 1 is smaller than this 3 in terms of value. And then we also found, okay, 3 has the right child, and this 4, so this 4 is greater than this 3. Okay, now finish 3, we also check this 1. This 1 has no left child, right? However, he do have right child. So you see the right child is 2, and 2 is greater than 1. So obviously it's a binary search tree. Okay, let's see what the question asks to find. Well, this question asks to find the case most random of all values or nodes in the tree. So for example, here we want the smallest element in this binary search tree. You know, binary search tree, the smallest element is always the left corner. So this will be the 1. And in this example, we have slightly bigger trees and want to find the third smallest element. So let me draw the graph to help you understand. Okay. So see the first smallest element is the left corner. So this is 1. So this is the first smallest element. Then want to traverse from left to right to find a slightly bigger element. So you traverse here to here, and you find, okay, this 2 is the second smallest element. And we do the same thing. We traverse here to here, so left to right, and found, okay, this 3 is the third smallest element. And we satisfy this result return 3. However, what if we have to find the fourth smallest element? In this way, we cannot traverse this 3 to this 5. This is not valid because we also have this right child, this 3, which is smaller than this 5. Okay. So if that is the case, we want to find the fourth smallest element, then instead we have to visit the child of these 3, right? So you see the right child 3 is 4. So you will have 4 here, and 4 will be instead the fourth smallest element. Now what if we want to find the fifth smallest element? You see we have for this 3, we have visited the left child and right child finished. So this subtree is finished. Now we found the fourth smallest element, then we have to check further right direction. So we check right direction, and we find, okay, this 5 is the fifth smallest element. And what if we want to check the sixth smallest element? Well, you see in this node, we have finished the left child, but not the right child yet. And you see do have right child 6 here, so we'll include this 6 and traverse 5 to 6, and this one with 6 smallest elements, and we're done. Okay, now for the intuition, we know we are traversing all the way from left to right and check all subtrees and finally return the result. Let's think how to save the coding part. Well, our intuition is here. So from left to right, we'll append all the nodes and we want to go left. After we have traversed into the most left elements, then we want to pop the node and want to go back. So from left to right. If found the elements, for example, is 3 here, right? Then we immediately return this value. But if we don't find this element in a specific path, then we have to check the right subtrees. Okay, now let's think how to code this stuff out. So maybe I'll scroll down to help you understand. But first, we need a stack. You don't know stack is simple. Well, stack is a last in first out principle. So for example, if you pop the nodes, and it will be 1, 2, 3, 4 maybe, right? But if you pop back from the stack, the sequence will be 4, 3, 2, 1. So in this case, for example, if you want to traverse in this 5 to 1, your original pop push the 5, 3, 2, 1 into the stack. But you pop the elements out, it will be 1, 2, 3, 5. So you see you are traversing from right to left, but when you pop element, it will be left to right, and it will help us to find the case smallest element. We're now finished start explanation. Let's think how to solve. Well, while true. So we are continuing this while loop. we want to copy paste all the intuitions into our coding comments to help us write code. So let me spend time to copy paste this code here. Well, the first thing I mentioned before, we want to append node and go left. So while the root has not end, this means the root still exists. We want to append the node to stack. So we just append this root to stack. And we want to go left. So root equals root.left. And we finish that. This means we have visited our road from right to left, and we have arrived at the most left value. If that's the case, we want to keep pop node and go back. So we'll pop node from stack using the pop function. And let me record this one in root. Okay. And now we'll since we want k smallest element, so up to here we have the k value, right? I want to call back. We want to deduct k by 1. So why do do that? Well, if we deduct k by 1, we go back, and if found okay k is equal to 0, this is exactly the k smallest element. Okay, I mentioned before it's k equal to 0, then we have to immediately return the root value because we have found the exact element. But otherwise, as I mentioned before, for example, in here, we found 1, 2, 3, and still not requirement, and we have to check all the subtrees of this root. So we have to check the right child. So root equals root.right. Okay, now deduct this, and then submit the results. Okay, the run code results good. Let's submit it to see. You see the time capacity memory usage of the equation not bad, and overall since the coding part is very easy to understand. Okay, if you like this video, please subscribe to my channel, and I'll see you next time. Thank you for watching.